We had studied few numericals in the last lecture. Now we are going to study further. Today the formula that we are going to use here in the numericals will be these four. This denotes resistivity. R, resistance. A, area of cross section. L means length. P denotes power of the circuit. Voltage, current. Power, current, resistance. Charge, current, and T denotes time. So the first question that we are going to deal with is, what will be the resistivity of a metal wire of 2 meter length and 0.6 millimeter in diameter if resistor of the wire is 50 ohms? As we see the question, it is very clear that we are going to use this particular formula. So firstly, just see that the thing that we are given is in the same unit or not. So this particular thing is 0.6 millimeter and this is in meter. So we need to change this into SI unit. And this is a diameter. What we require over here is radius. Like if in these kind of sums, if the diameter is given, the first thing that we have to do is convert it into the radius. So radius will be 0.6 millimeter divided by 2 will give us 0.3 millimeter, and that when we convert into meter, it becomes 3 into 10 raised to power minus 4 meter. 0.3 into 10 raised to power minus 3 meter. So if we want to take that point away, then it becomes 3 into 10 raised to power minus 4 meter. Now this particular thing is done. Now what is A? A means area of cross section. So area of cross section of a wire is denoted by the formula pi r square, because that is a circle. So 3.14 into what is radius? 3 into 10 raised to power minus 4 square. 3.14 into 9 into 10 raised to power minus 8. 28.26. If we multiply this to 10 raised to power minus 8, this becomes 2.826 into 10 raised to power minus 7 meter square. So this is the first part. So now we have found out the area of cross section. We will simply put everything in the formula. What is our resistance? 50 ohms. Area that we had found, 22.826 into 10 raised to power minus 7. Length is 2 meter. So it's 2. We solve this. We get 70.65 into 10 raised to power minus 7 ohm meter. So this is how we have got the answer. This is our answer. Okay, so this is our second sum. The sum says the area of cross section of a wire becomes half when its length is stretched to double. Means the length is doubled, but the area of cross section is made half. How the resistance of wire is affected, then how this resistance, just keep in mind, they're not talking about resistivity, they're talking about the resistance. So we are supposed to find this. So if we convert, if we adjust this particular equation, then we find out that R is equals to rho L upon A. Rho means resistivity. So what they have said, that the original area of cross section is made half and the length is double. So area of cross section, original area of cross section is A. CS means area of cross section, and length, original length is L. Resistance, original resistance of wire is R. Now the new area of cross section becomes, A by 2. Length will become, new length will become 2L, because they have said it is double. So, and new resistance becomes new resistance becomes R1. So keeping this in mind, if we take the ratio of old resistance to the new resistance, then we get something like R upon R1 is equals to original formula. And for the new resistance, L becomes 2 times L, area becomes half of the original. Now, using the algebraic rules, we get something like this. If we take this 2 upwards, becomes 4 summation L by A. And if we, divide, if we cut it further, if we divide it further, we get R by R1 is equals to 1 upon 4. So basically new old resistance is 1 by 4 times of new resistance. So here we say that the resistance increases 4 times. The resistance increases 4 times after stretching the wire. So the new resistance is 4 times of the original resistance, and by this we can conclude that the resistance increases 4 times when we stretch the wire. Okay, so moving forward to the third sum. A radiator working with 30 volt potential difference, PD denotes potential difference, I'm just using shortcuts, has power of 180 watt. Find current and resistance of radiator. So if we see, we have two formulas that has power involved, this and this. But just see, we have given here voltage and power, and we have to find the current. So we'll be first using this formula. So this, and keep this in mind that we have got this particular formula using the Ohm's law. When we put Ohm's law here, when we apply Ohm's law here, we use this formula, V is equals to IR. Using that formula, we have just got this formula. So both of them is the same formula. The power is equals to V into I. Power 180, voltage 30 into I. We are supposed to find the current. 180 upon 30 becomes 6 amperes. Now we can also use this particular formula to find it out, or we can also use Ohm's law, this formula. So we'll be using Ohm's law because that is quite easy. 30 upon 6, if we solve further, we get that resistance becomes 5 ohms. So in this way, we can use 3 different formulas to find this particular answer, and we can use the same formula in the different questions. Moving on to the fourth sum, we are supposed to find R2. R1 is 1 ohms, voltage is 6 volt, and the current through the circuit is 0.25 ampere. So we are supposed to find R2. Now just keep in mind, like I have told previously, that when there's no other branch in between two resistors, then we consider them in series. These two resistors are in series because there's no third branch between them. So if by using the equivalent resistance formula, we can conclude that equivalent resistance here is R1 plus R2. But we have RS. We have that, but we do not have this particular thing. So how do we find it out? We simply get formula in terms of R2. So R2 becomes RS minus R1. If we just substitute the formula, then we say that but still we have not got this two resistors. How do we find it out? we have voltage, current. So we can find out the equivalent resistance, because equivalent resistance will be the final overall resistance in the circuit. So Rs will be V upon I. What is voltage? 6. Current is 0.25. So we get Rs as 24 ohms. By solving this further, we have got that. We can simply put this particular thing here and get R2. That's what we are going to do. R2 will become 24 minus 1, 23 ohms. Now, the only thing that we are supposed to find is the power across R2. That's what we're supposed to find. If we have to find power across R2, then how do we find it out? Stop this. We have two formula for power. Power is equals to V into I, and power is equals to I square into R. So Vp is equals to, we are using this formula here, 0.25 square into R, 23. 0.25 का square into R into 23, if we find it out, it becomes 1.44 watt. You guys have to solve as a homework. Just pause the video, note it down, and then solve it. Thank you.